Hello and welcome everybody to the first session of Advanced TypeScript Trickery. So we already informed you before that this should be a little bit different than an ordinary meetup. The idea is that we have rather a conversation than, let's say, a collection of monologues and talk a little bit more about advanced, interesting TypeScript stuff. So I guess most people watching today are familiar with TypeScript. If not, it's also fine. You can later look things up that you didn't understand. But the idea is really that TypeScript is a very powerful language that allows you to do really awesome, complex stuff. And in a normal meetup, we oftentimes don't have time to really dive into these deep topics. Oftentimes, we also need to assume that people don't know TypeScript very well. So we need to introduce the basics. And once you introduce the basics, time is already over. So the idea here really is that anyone can come up and can talk with us about anything they're excited about, that you are excited about. So we rather want this to be a little bit more interactive. So what do I mean with interactive? You can participate in two ways. You can watch, you can also ask questions if you don't understand something, and you can also tell us something about a topic that you are interested about. If you have anything that you want to talk about, then you should reach out to Natalia on Twitter. I think Natalia is going to write her Twitter handle in a bit in the YouTube chat, so you can check that out. Um, and if you have anything interesting you want to talk about, you can just DM her, and with that, we can get you on the stage. Today we have already, as we got many CFPs, it's not really a call for paper, but it's still, we needed some mechanism to already ask people what you're interested to talk about. And we have already 3 people scheduled for today. And we still have one free spot. So anyone who's interested, just write in the YouTube chat and we can get you on the stage. Good. And it would be boring if I would just have a conversation on my own here. Actually, there are a couple of people here. We have a few other people, actually. And I would like everyone to do a quick introduction. So I think I even didn't introduce myself. I'm Tim, and I'm a software engineer at Prisma. Why don't we continue with Craig?
Hi, I assume this is working.
Yeah.
Hi, I'm Craig. I'm a senior engineer at Spotify.
Awesome. And the next person, I hope I'm saying your name correctly, Poom.
Yeah, I'm Phung, and I'm a developer advocate at Brickle.
Awesome.
Thank you.
Yeah, welcome. Next person, Bogdan.
Yes, hello everyone. I'm software engineer in Flixbus, and yes, I'm Bogdan.
Now Bogdan became Simon, is also okay. And now Simon.
Hi, I'm Simon. I'm the founder of Quirrel, which is like a task queuing solution for serverless, and I'm also one of the contributors of the maintainers of Blitz.js.
Awesome. And then last but not least, Remo.
Hi, I'm Remo, and I'm the founder of a company called Walk Software, and we do consultancy for web development apps.
Awesome. So first of all, welcome everybody, and thanks for participating in this new format. So the idea is a little bit here that we can also, if we do it politely, interrupt or ask questions in between. Because if you talk about advanced TypeScript, sometimes people might get lost. The more advanced it is. So I think the goal is really that we can take some more advanced ideas and prepare them in a way, explain them in a way that more people can understand this. We didn't really define the order, but I will just do that now. Craig, do you think you could start?
Yeah, let's totally do that.
Awesome.
Let me just start with a slight preface that I am super jet lagged. I flew back from Australia to Sweden yesterday, so trying to stay awake, and we'll see how my brain goes with like fancy TypeScript stuff.
Yeah. So first of all, welcome and thanks a lot for being like up for talking here. This is a new format, and yeah, So what did you bring us today? What do you want to talk about?
So what I think is one of the more interesting things coming out in the TypeScript world recently is with the 4.1 release, we have these template string types. And so if people haven't seen them or haven't heard about them, it's a pretty powerful new mechanism for being much more specific about the types of a string. You can kind of do type-based checking on smaller parts of strings. You can actually even write parsers in the type system, which gets pretty crazy and pretty powerful pretty quick.
Nice. Yeah, I mean, that's a really powerful concept. I didn't look into it yet that deeply, so that might be even good now that I'm a bit someone. I can represent a bit the people in the audience who don't know this yet. Do you have any example or anything you want to share?
Yeah, let's. I'll share my screen, and I'm just going to pull up. Let's see what it's gonna say if I do this. Maybe. All right, cool. So we just got the plain old TypeScript playground here. Hopefully that's
important.
Yeah, hopefully we can see this. So let's start with some basics. We have just a TypeScript string, and let's just say I have a type hello equals hello. This is just normal string types. You can do things like this.
So that means this is already a subset of the string type, right?
Exactly.
And if I say hello 2, that's not a valid instantiation of hello anymore, right?
Exactly. So if I was to do hello 2, this fails. We haven't got the right type yet.
And this is something TypeScript already had before 4.1, right? That you can type a specific stringlet. Yeah.
Correct. And so the way that makes this new feature quite powerful is I could do type hello 2, and then I believe I can just do hello 2.
Oh.
And now if I make this type hello 2, this works.
Okay.
So this by itself isn't particularly powerful, right? But let's just, I don't know why I wrote a var, must be tired habits. You can do slightly more interesting things. Say, for example, type hello world, whatever, equals hello hyphen world, or whatever that is. But you could also do, I think it's capitalize.
Oh, okay.
Now we have this type of hello world, which
whoa.
Why did that not work?
So I guess you can also do things like camelize or like snake case and these kind of things.
So there's only a few. I feel like there's lowercase and lower to type. I guess there's upper.
Just a quick point here. Natalia just opened her DMs. So anyone who wants, it sounds weird, but anyone who wants to land in Natalia's DMs, you can now write her to talk later here at Meetup. Okay, sorry. Back to the strings. Yeah.
And so you can see here that this is doing exactly what you'd expect.
Now I would be wondering, how did they implement the uppercase? Can you see that in the playground?
You can't in the playground. I assume it's somewhere in the code. But where it starts getting pretty interesting is if you can do some things like, say we've got type red, type blue equals blue, type I guess green. Then I can go type here's equals. How does this work? Let me look at my notes quickly while I figure this out. Yes, sorry. So if I do colors, that's what I want to do.
Like a union of these types, yeah.
Yeah, and then let's do type.
Okay.
Brain. Then you can basically do a third type, say type color number, which would be colors.
Okay.
Numbers,
Ooh. And it's doing it distributed basically, or
numbers.
there's a backtick missing in line
Oh,
10.
You're right. There you go.
Yeah.
Oh, come on.
And smart autocompletion was too smart. Yeah.
And so now you get a combinated map of those things.
That's powerful. So
So
it's a
that-
little bit like with conditional types that it's they have a distributive nature. So that
Exactly.
if you have these union types defined, that it's always on all of them, right?
Exactly.
Okay.
And so the next place where it starts getting especially interesting is, let's do something like, what's a good example? Trying to think of one off the top of my head. Let's see. Let's do maybe a split function.
Okay.
So let's go type split. And the way that this would work is, I'm just going to copy something here. We do something like this. Why is that freaking out? So we can read it a bit easier. So what we're saying here is we're going to have a generic type which takes two strings. The first one is a string that we want to split, and the second is a character that we want to split it on. And now we've got a fancy conditional type where we're doing infer on the internals of the string. And so we can do, for example, type, let's just call it A equals split, and let's do hello world, and then let's do space. And now type A is, why did that not do what I expected? Oh, because that did character. There you go. And so what we're essentially saying here is we pass this string and do kind of a pattern match on this part. And so it finds the space in the middle and then infers our two chunks of that. So I could also come here and I could go, say, E, and I'm going to get the first start of the end start. Or I can do R, and I'm going to get the start and the end.
Whoa, that's powerful.
This
So
and
the question, what are next natural question, what are use cases for this? Real world use cases. Have you seen some already?
So some people have done some pretty interesting stuff. There's a couple of links that I'll see if I can find to share.
In the chat, someone asked for increasing the font size. Could you?
Oh, let's see if I can do that. What's this going to do in the middle? It might be. Maybe. How does that work?
And someone wants to split an O. Maybe you can try that out.
Yeah, so what I expect will happen here is it's just going to split on the first character.
Okay.
Oh, it kind of did what you expected.
Okay.
Right, okay, and that makes sense, right? Because we've actually got a recursive type here.
Recursive type.
So we've got the recursion of the splatted split, which...
If it wouldn't be recursive, what would it be then?
I guess we would probably do something like this, right? And you'd end up with...
Then it would indeed start with the first O. Yeah.
Yeah, which kind of makes sense.
Makes sense. Yeah.
And so use cases. There's been a few really interesting ones, and I think this is where TypeScript shows off exactly how powerful it is, right? JavaScript is incredibly dynamic in its nature, and instead of what most languages do, where they come and say, "Look, you just can't do that," TypeScript had to approach the other direction, which is saying JavaScript can do that. We need to figure out how to type this. And so, for example, some places where we always pass strings around, there's document.query selector or new date, for example. We'll pass a string in here. Wouldn't it be awesome if you could know that what you passed in here was syntactically valid as a date? or what was passed in here is syntactically valid as a query selector, exactly. So there are definitely some of these use cases, and I'll see if I can find, there's a link that someone has been curating of a whole bunch of like pretty wild use cases. Where's my...
So we got some comments here in the chat. People mentioned that according to a PR, apparently lowercase is an intrinsic implementation as the playground said. So this is not something that you can look up, like types like required or partial. So yeah. And then Baptiste mentioned that it's only recursing on the second part of the split though.
Yeah, I guess we could do.
Yeah, that's true.
Right, and make it do the proper thing.
Okay, now we have Emile saying that you, aka Sutton, he's active in the Prisma community.
Nice.
Hi Sutton, you only need right recursion if you match the left char. But is it splitting at the char then? If you, that's the question. The infer, would it split at the char?
So this is gonna find the first instance of the character.
First instance.
Yeah, I'm fairly sure. Yes, yeah, it should do. I'm sorry, I'm still trying to find this link.
Okay, no, then it should be fine. Like if it's splitting on the first instance, I think then it's fine. Someone mentioned my mic is not loud. I can increase the. Am I louder? Am I louder now?
Let's see if I can share this link.
Yeah. Awesome template literal strings.
Yeah, so there's a whole collection in here of some interesting things that people have done. Yeah, like I said, document query selector. We've got Angular route passing. We've got JavaScript expression passing. Yeah, there's some pretty cool stuff in there. Oh, it's even grown since I last looked at it. So yeah, there's some pretty powerful stuff that you can do here.
It seems like the TypeScript compiler will be happy about this because this is expensive to calculate, I guess. Like if you now have an application written, an Express application, and suddenly validating your routes, then I guess this is now heavy. But this is really interesting also for SQL parsing. Emile is mentioning that's also a nice use case.
Exactly.
At Prisma, we, for example, allow, and Prisma, for the people who don't know, it's like an ORM, and we map JavaScript types to database types, and that's always tricky. And what we allow is, for example, for date type, oh, can you use regex? For date type, we are allowing a string. But it has to be an ISO string with ISO, what is it, 8601 standard. Why? Because if you don't provide the timestamp, you can shoot yourself in the foot. Typical example, you have the server in a different time zone, and then where you are, let's say you're in Europe, in Berlin, and you deploy your application to Ireland, that's 1 hour behind. So now you do all your beautiful daytime stuff without the time zone bar broken. And then you can now use these template literals to not allow that you say it has to be this particular format of a date. And I guess some people probably already added. It's a bit like a regex, right? Someone just asked, can you use regex? I guess you can probably make regexes with this, right?
Yeah, it's very similar. So here's a gist that I'll just share. I'll actually just pull it up because we can walk through a bit of it together, which is exactly what I kind of mentioned, a date parser. So it gets pretty damn gnarly pretty quickly. You can see here we've got a lot of types.
Is it just the ISO standard here, or are you allowing anything that the date function is allowing?
So this is
down there you have a couple of examples.
Yeah, so this is just the ISO standard for now. And these are basically my tests at the bottom. So let's actually just.
Emile doesn't see the pasted link. Can you paste that again in YouTube?
Oh, sorry, I can. Let me just do this as well.
Yeah.
Thanks. Yeah.
Perfect.
Sure why that's not working.
But I think you send it. Yeah, it's weird. I think should be fine. Should appear. Maybe a lag or something.
hopefully. And so if I pull this out just a little bit, we can see that
Okay, interesting.
I should be able to say break this by going. Yeah.
Yeah.
So that one's now giving me a pass error. So the place where this gets a bit fruity is you'll if you create a combination which has more than 10,000 items in the union, then the compiler goes no. So that's been the case for a while, I believe. I think it was introduced when union types were first introduced. So there was a max limit to how many you could have.
So in other words, if you would do this on a character level and you would have 10,000 characters, that's the limit that is possible, right?
Exactly. And so the reason that it works with dates, whereas some previous stuff that I did, I tried passing. Oh, I can't even remember what it was. It was something to do with CSS. Let me see my gists again. Yeah. So here I was. This was an attempt at a CSS lexer. But because it was a lexer, I was going character by character, which very quickly became too explosive.
It's kind of okay, right? Because it can just jump over a couple of points. This state parser was from a different URL, though. Someone mentions.
What have I done?
Is it a public gist? Because then they can just go on your GitHub and look through your gists. Yeah,
it should be public. Yeah.
Okay, then you can check out his GitHub, and we are, I think, also saving this recording anyway, so people can just type this worst case by hand. That's really awesome. Thanks for sharing.
No worries. Hopefully that's useful for someone.
Yeah. Are you already using that kind of stuff at Spotify, or is that still like rather experimentation?
I would not be probably using this stuff in production on anything yet. I don't think we've actually got to 4.1 yet, so we couldn't, but I'm sure it'll be somewhere in the future.
Okay, I didn't pay attention to our private chat, but I see we have a new person in our chat called Piotr. As we said, we want to highlight what people want to, anything that anyone wants to talk about. So I guess we will just introduce Piotr now. Welcome.
Hi, hello everyone.
Yeah. So
can you hear me well?
Yeah.
Okay,
so,
awesome.
We just lifted you up from the stream, I guess. From YouTube, you just made it into our stream here somehow magically. So yeah, Piotr, maybe you can introduce yourself.
Of course. Okay. So I'm a software engineer at Flickr, but what's more interesting, I'm maintaining TeamUI, the CSS and JS library. So if you don't know it, can I share my screen?
Yeah, I think we can directly. Let's jump into it in a second. I wanted to quickly ask a bit people like what their experiences with template string types, or if anyone has used them already from people here around. Has anyone else had experiences with them already?
So my topic kind of goes into that.
Perfect. Okay, then I think that's a perfect transition. And I think we will just continue with you, Piotr. We still have two more people who will also share something, Bogdan and Pum. But I think then we just bring it up for Piotr.
Okay, awesome. Thanks so much. All right, so like I mentioned, maintaining a CSS and JS library. And what TypeScript gives us, TypeScript needs to be a powerful language to deal with JavaScript's bullshit. But a side effect of that is that using template literal string types and using conditional types in all of these powerful features that don't exist in conventional statically typed languages because they're just not needed there. And you don't exactly need these features to build good software. You need it to deal with JavaScript. And they are also useful to create embedded DSLs. So in TypeScript syntax, we can build mini languages. For example, for styling. You may be familiar with Emotion. TeamUI is an abstraction layer on top of Emotion, which not only transforms your objects with CSS prop into styles, it also replaces your design tokens from the theme you defined previously. You can just use them as their first level constructs. And currently, before TypeScript 4.1, this was okay. I mean, you could use that, but you didn't get that sweet TypeScript autocomplete on that. Because every user defines their own theme, but we can't exactly type check through that theme because it can have deep objects here inside. And how do we get a theme from the user, its exact type, to the library? So this is topic of my talk, and let me show you that.
Awesome.
All right. So this is not yet released. So you are seeing bleeding edge changes to TeamUI. But here, currently, we would define our theme like so. Let me import. Actually, I'm going to listen to my own comments, and I'm going to make it a bit bigger. Can you see it now?
Yes.
Okay. Let's
You
import
were the
theme.
one who said it should be bigger font size. Good.
Yeah.
Good that you're listening to yourself.
Okay. All right. So now the theme is imported from somewhere.
Okay.
You would import it from TeamUI.
Library, yeah, I guess.
Yeah. And right now we get that sweet TypeScript language support for while we define theme, right? So we can define colors, and primary is one of the names we suggest. And right now here we have support from CSS type. So there are all of these keywords from CSS that are supported.
Okay.
But
that's really awesome.
That's just key reunion. That's not really great for performance, and we don't really care that much about it. But here, when we define, let's say, okay, this is bad primary color. This one will be better. Right now, when we define that, we have nice support and everything is smooth. However, if we use that, if we import CSS from TeamUI, and I'm going to import it from SRC because I'm inside of the repository. And if we use color here, we just get a bunch of global values. Of course, we can write primary, and this will work. But we don't exactly know what the user defined, right? Because types are declared in the library, and this is user space.
And you are typecasting it in line 62 to theme, so the type information is lost, kind of.
Yes, the type information is lost, but I can use a small hack like this. So this is just an identity function, right? But it constrains the generic parameter to the base theme. And if I use this constructor function here, I'm still getting my sweet support here, but I'm preserving the exact type. it's inferred by the generic function.
Nice. Because can you open the make theme again so that
Yes.
we understand it? So that means basically you're taking the T, you have a base constraint on it, and you can still infer that. That's perfect.
Yeah, we only use it for inference. Yeah. This function does exactly nothing. If you use Clojure compiler, it will get optimized and it won't appear in your code.
An identity function, right?
It's just an identity function.
Okay.
But
yeah,
it allows us to do.
We have the space constraint now. And
yeah, it allows us to do this base constraint, because right now, if we did this, we have that exact type, but we have no support here. Yeah. So this small one-liner hack gives us support from this side and exact type from this side. Well, maybe if I could add whatever I want to TypeScript, we could have a keyword for that, right? Like write extends theme, base theme here. But this is what we have. All right, so I have that exact theme, but the next step is getting it here, right? I defined it in my user code, but I need to inject it into a library. Another cool TypeScript feature that exists because TypeScript is a language gradually typed, used for migrating JavaScript projects to statically typed language. And a really cool feature for that is module augmentation. So if something is missing from a library types, we usually do this, and we kind of fix these types in our code base, right? Or we contribute to definitely typed and provide type declarations for JavaScript libraries. But I can also use it to inject my stuff into TypeScript libraries in places where they expect it to be. So I can use it on my code, right? Maybe it wasn't thought of as so. Maybe it's not intended, but it's a feature.
If it works, it works.
Yeah, if it works.
I will not remove support for that. So
there is, as you can see, there is no support for paths here, but I can just use my local path. As a user, I would do declare module TMUI. But here I can you can also use it in your applications, in your code bases, and inject types into different files. I'm not recommending to do that often, but you might find some use cases for this. Okay.
ESLint by default has a rule against that, if I remember correctly. I think there's some ESLint rule around that. But
there's a ESLint rule not to do it?
Yeah, that's if you have a .ts file, I think then they are a bit sensitive about it.
Oh, there's certainly in the base in ESLint TypeScript default preset, there is a rule not to use namespace and not to use model, because these are like these advanced features usually for definitely typed maintainers, and
you can shoot yourself in the foot, maybe. But
you can.
Continue.
It's if you're teaching somebody to program and just like using TypeScript instead of JavaScript because it's a bit more a bit less error prone. You probably shouldn't show it to them yet. But this is advanced trickery, right?
We are at the advanced TypeScript
meetup,
so you can
my team here, this is what we imported previously. But we also export user team. Let's take a quick look at this. As you can see, this is work in progress. This is an empty type. Empty type left in a library source code.
Okay.
It's used here only for user module augmentation for declaration merging. So module augmentation is this thing, and declaration merging is when we declare an interface or a class or a function for the second time the names are merged.
So that means this is basically a hook point, how I can get from my application into your library, basically, right?
This is a hook point.
The gateway.
So
the gate.
Here, the theme, you can see it already. The theme is base theme overwritten with user theme. So whatever you define here will overwrite my base types in the library. You can break stuff, obviously, but if you use this make theme constructor, you won't, because we ensure that the base constraint is still here. All right, so let's take my theme, type of theme. Let's add maybe spaces. And just write SM or let's do it like this.
Okay. Just quick reminder, we need to look a little bit on the what, maybe like 3
Okay.
minutes. Yeah.
Let's I'm finishing right now, sorry. Okay, so here we declare that interface user theme again, and we say it extends my theme. We don't need to import it. This is not used. But here, right now, we can see primary. And here I can say meetup. And this will also work.
Okay. Whoa. We had some people, I waited a bit to read it, but we had some people in the chat mentioning that Nexus is using similar pattern. They, however, use a global module also to inject types from user space into Nexus, basically. So that's for sure a pattern. I think Nexus is quite successful with that pattern. They do it for 2 years or something already, and it seems to work. They generate that code for you. I think what's different in your example now, you basically ask the user to write that code, which also has advantages that it's something they control, something they see. But it's an interesting pattern.
Mm-hmm. Okay, so that's all. Thank you.
Awesome. That was really cool. I mean, this is really bleeding edge. And now I'm not using Theme UI. I just landed on Tailwind somehow and don't use anything else anymore. But still, this is really something that's really interesting. And actually, we have one of the Nexus maintainers here, Jason. Jason, what do you say about that pattern?
Can you guys hear me?
Yes.
Cool. Yeah, no, it's interesting. I think with Nexus, the global approach has worked well. The one downside, it's been that making multiple schemas in a project can be kind of a pain. And so the assumption was very just effective when you do only have one GraphQL schema, but it can be more complicated. You have to have multiple TS config projects when you need to maintain. Well, potentially, it also depends on the typings are generated as a file. So if you organize your project in such a way that you import those different files, so it's possible. It just can be a bit trickier. Yeah.
Makes sense. Yeah. Awesome. Yeah, so it's really awesome to see these new patterns and libraries because I think it's providing a lot of DX. And then from the panel here, does anyone see like a way that could be maybe used in a library that they're working on or anything?
Well, we actually use that pattern in Blitz. We use it to allow people to inject the types of their sessions. So whether their user IDs are like numbers or strings and other stuff that we want them to have in the session, because the session data is part of the data that needs to be passed through the framework. And we want to give the users full type safety in there, and that works fine, or that works really great with the declare module set up. And I think it's a bit of an advanced feature to ask of users to have to use that. But in Blitz, it works because we generate that code for you. There's like that big starting project where that's already part of it. So it works fine in that regard.
Yeah. So maybe Theme UI seems to then be the first library asking users to do that. But let's see. Yeah, that's really awesome to see also how Blitz.
I mean, I don't think we're the first library asking people to do that. So this pattern isn't really new. We are starting to use it right now because these colors objects can be deep, and before TypeScript 4.1, there was no way to generate paths from that. And I can maybe share a screen for 1 second more.
Yeah, okay.
And right now, we can use this lovely type to
iteration. Interesting.
Yeah, to generate red.100 from red new object 100.
Whoa,
and so this part is actually this also works. So this is quite cool.
Yeah.
I didn't expect that from TypeScript. Oh, sorry. This needs to be a bit bigger. Anyway, but I think the first library which asked people to do that was Overmind, the state manager used by Overmind.js, the state manager used by Code Sandbox.
Interesting.
So in the TypeScript chapter, they you don't really ask people to do that. You ask them to copy it from the docs.
Okay.
Right. I think this is the first place it was implemented in. The first library.
This is really an interesting pattern. It's exciting to see that, and let's see how that will still be used in the future by other libraries. We are a bit short on time, so let's move on with the next presentations. I suggest we move on with Poom, I guess, who will tell us something about a game engine.
All right. Thank you. Can you hear me clearly?
Yes.
Sweet. Yeah, okay. So first of all, I'm not really a game developer, but I found a really nice architecture pattern called ECS, so Entity Component System. So I'm gonna share my screen and talk a little bit about that first.
Yeah.
Okay. Can you see the screen?
No, not yet.
Oh, okay. Yeah, there we go. Okay, so I guess this works now. Yeah, so in ECS, there's basically three things: entities, components, and systems. So when building a game, a lot of data is kind of duplicated. For example, for a player, we have the position data and a texture data, right? But say an entity in the game, like a wall or maybe a drop object, they can have the same data. So therefore,
that data, so to say, but different entities. Okay. Yeah.
Yeah. Therefore, we can therefore we kind store the data as a separate component, and then we reference that from our entity. So entity is just storing that as an integer or a UUID, and then an array that points as a string array that references that component. Yeah, and then there's systems. So what system do is they query data from the components. So system kind of asks what data do they want. For example, my movement system, they might want to know which key is pressed, and whether what speed the player is in, and where the player is in the game. So when they know all that data, they're gonna use that to determine what to do. Yeah, so that's pretty much ECS. And the implementation is pretty easy. Yeah, so I'm going to show like the code here.
And this
So
is
first,
sorry to interrupt. This is basically for the people who are not game developers. This is, I think, also the usual way you do it in game development, right? So if you would say in React, you do components and you have this like stateless rendering, I think this is, in my understanding, pretty much state of the art if you do game development, right?
yes. So the reason like people use ECS is usually when you're doing not on the web, like be on mobile, a lot of data is shared. For example, like the character mesh or like the texture. So when you store data as components, it can be reused. So here's my API surface in TypeScript. So first we have like the systems and the entities. So I created like a little helper function here. So you can just call add entity and then give it the name of the entity and then what data you want it to have. Like I want the player to have this particular position. Yeah, and then there's systems. So for systems, it is like an object which describes like how the data, like how should we query the data from the component. For example, here I say that I want the data like to be the position data, and then I also want the texture data. So that gives us enough information to render the texture.
So that means you are basically specifying your data requirements there, right?
Yes. And then there's like the lifecycle functions. So like these queries, they can run either on setup, so that means when the game is loaded, or either on tick, so that's run every single frame, like updating the position of our character. And then there's cleanup. So this runs right before the entity is removed. Okay. Yeah, so as we can see, like the API surface is pretty small. So I'm gonna show you like the TypeScript part. Yeah, so the first thing, like the first problem I saw when doing this was when creating the entity type. Yeah, so first, so say we want to create like a player type, right? We would do something like this. Maybe like the player can have the position of I position. But then the problem is the key here isn't type safe because we're going to be using this key to query the data requirement. So say if we like misspell something, then it's gonna like be really annoying to debug. Yeah, so this is like where my first type come in. So this is with components. Okay. Yeah, so with components, like I think the best way to explain TypeScript types is to break it down a bit. So let's start with this part first. So this is just like basic conditional types. So we kind of like the input here is the unit of what data requirement we want. Like do I want position or like a collider or a texture? So this is like, so here I just want the texture. Say I want this. And then if the conditional type checks that texture is indeed like in one of the unit, then it's going to like allow that. So here it indexes the component map type. So here is just a map between the name and the actual data. So the data here is just a simple object, like the position is just X and Y, the movement is just the speed. Mm-hmm. Yeah, so in here is like pretty neat. So you don't have to worry about like misspelling the types anymore. So here it just says that like if the key is in the union of like what we want, then we get the actual type. Yeah.
Okay. So that means this I component type that is okay. So where does the K come from? You're looping through all the keys of I component type. These are the possible component types that exist. And you're basically packing them out. That's the default here for R, right? You're calculating R that way. I guess you could also have put this statement between line 4 and 12. You probably could have put that in line 14 as well. that like as a nested statement, but I also like this that you're like using this as a variable. It's more readable, and you can add the comments in line there. That's pretty nice. It's a nice pattern.
Yeah, I usually see in many cases like you have like a lot of generics, like a lot of types you have to use, and like doing it this way is kind of like more linear and more readable. Yeah, so here like the way it excludes is using like the conditional except from typeface. So for anyone that didn't know, typeface is kind of like a collection of types. So here, yeah,
who's powering half the internet.
yeah, definitely. So usually like the Boolean type, there's a lot of them. There's like exclude, there's like pick, but like time and time again, you're gonna find yourself needing something that the standard library doesn't provide. So I think this library is like really good in providing that. And if you have like any types you want to share with the role, you can send a pull request here.
Could you quickly repeat where you are using the with component type that you defined?
Oh, sure. So in with component, this is used in each of the entities type. For example, yeah, I want this player type.
Basically, out of these, it builds up what you want, basically, right? So
yeah, it's a specifies.
A little bit like a, let's say, pick, right? But a special pick in your case because it's just picking out the ones that you defined upfront.
Yes.
That's pretty awesome pattern. We already have to switch back to the main panel because we just have 8 minutes left. We will probably be a bit over time, like less than 5 minutes or something. But yeah, thanks a lot, Boom, for showing that. These are really awesome patterns, and I think something we can all learn from when we are building our code. And our last speaker today, I know it's a lot to process already for the TypeScript compiler built into the head. The next speaker is Bogdan.
Yes, hello. Let me share my screen right away.
Yeah,
screen
welcome.
Like this. And you should see it right now. Do you?
Yes.
Yeah, and it's like the usual problem when you do some front-end application that you define a lot of types, you have some logic with this, and then you accept some data via API, and it could be anything. And you can actually assume it's the data you expect, but this assuming doesn't work really well, at least once, and it's enough to crash everything. So actually you need to somehow validate the data and to check that it matches your expected types. For this, TypeScript provides type guards, but type guards have two problems. First, it's a lot of boilerplate you need to write, and usually it's fixed by some validation library. But another problem, which was very big problem for me in about April, that this is also a valid type guard that just assumes that everything is my expected type, and that's it. And that's bad because I need to take care about what should I write inside type guard. I need to test it, and later if my type changes, I need to remember to update my type guard because nothing will tell me that it's bad.
Happened to me already.
Yes. And the solution to fix this is using parser combinators, where like we have type guards which consist a lot of smaller type guards, and they all provide one big type guard for the thing you expect. So you do not write type guards manually. For example, you can have define a type guard like this, similar thing, same as TypeScript does. And then you can have a bunch of very small type guards for simple types. And then you can make thing that combines type guards. For example, isArrayOf accepts a type guard for some type and returns a type guard for array of this type.
Interesting. Let's quickly unpack that a little bit in line 6. You say item guard is a guard of A. Can you explain a little bit what that means?
Yes. So this isArrayOf is not a type guard for some specific type. It takes any type guard and returns a type guard for array of these types.
Okay. So it's, yeah, it's like a, let's say, a little bit like a type guard factory, you could say.
Yes.
Yeah. Okay.
Yeah, same for record type guards, but then here you have accept an object with every field in your type and type guard for this specific field. And
So
in this case, you
do a lookup in line 9, right? So you say you are going through all the keys of A, of this record.
yes.
And what are you doing now? You again call guard. And guard is your general function.
And guard is my polymorphic type. So for each key in type A, I expect a guard for this specific, for type of the field inside of this object.
Okay.
For example, if I had a type food with one field name and it's a string, if I want to make a guard for food, I call this type guard and I provide field name and I provide type guard for a string here.
Okay.
And this thing tells me that I cannot provide some wrong type. For example, if I call isNumber, TypeScript will complain to me because it expects a string type guard right here. And if I want
food and food name a string, okay, makes sense. Yeah.
Yeah, and if I want a type guard for array of foods, I have array and I provide type guard of food. So in this thing, when we have complex type guards composed of small type guards, every type guard knows its type. So if you expect a type guard of specific type, everything will compile only if your type guard is valid. And that's an interesting thing. So the thing you write for validating types are validated by the types they are trying to validate.
It's an inception. It's an inception. So
Yes.
that means you can really, as you do here in line 19, you can construct them, right? You can nest them. And you can say, I have an array of a object type that maybe needs to be a string.
Yeah.
And that is defined by having the guard of food. Okay.
Yeah, that's exactly what
So
you
that
do.
means you have your concrete implementation also here, line 7, like is array. So this is backed by the real JavaScript. And you really and X every checks if it is indeed that. And this is really fascinating because you may have seen the library IOTS. And there are a couple of libraries out there that try to tackle this problem. IOTS, I think Zot is one of them. And I never looked into their source code. I mostly implemented the type guards on my own, but it looks like you can do this like with just a few lines of code. This is really fascinating.
Yeah. So at the moment when I faced this problem, I guess Zot was not there, or at least it was not popular. So I wrote a bunch of these functions for our specific projects where we have where we had really big complex types, and then I thought it's generic enough, so I need to kick this source code away from our project into GitHub, and that's what I did. So there is one more library like this. It's called FPTS type check, and if you look there, it's not really looking like this. It's looking like this. There are one interesting thing: it doesn't return Boolean as a usual type guard. Instead, it returns either from ifpts library, and there it returns what exactly didn't pass the type check and where it happened. So for example, if we have type with name, amount, some nested type, and we have nested type guard for this, and if you provide some value, it shows you what exact field didn't pass.
This is really awesome. So it basically builds up this path to where it is not passing, and it can do that dynamically.
Yes.
Where's that logic that builds up this path?
It's in this composing type guards. So this one is provided in isType type guards. We know which sub guard we are calling. So if it returns there, we can say we can add a field into the beginning of this path and bubble it up. And if it's wrapped in another type guard, it will add more to the beginning of this path.
Okay. So do you use the template string types already for that? Or how did you achieve that? How is that achieved?
It's the same way as I showed with composing type guards.
Okay, but I'm just wondering in line 23 how this like string kind of like with the dot amount, dot count, how that is being constructed basically.
Yeah, it's using left map of either. So if we are calling some nested type guard and it returns error, we don't just pass it up. Instead, we update this error to add something into beginning of our path.
Mm-hmm.
And in any composing type guard, we know what we need to add. So for example, if we are validating for a type, if we are validating this field inside an object, we know that we need to add this inside the count, like inside path. If we are validating array, we know which index exactly failed, so we can add this to beginning of the path. One more interesting thing, I wanted to avoid it first, but since it's advanced JS trickery, one thing is this type parser. It's still a function, but it has some kind of phantom property that is never defined, but it needs for type trickery. Because otherwise, if you have type guard for string, and it's actually a function from any to string, you can use it as a type guard for string or undefined, because this one has narrower type, and TypeScript allows you to make this assumption. But when you look at this as type guards, it's obviously wrong, because type guard for string cannot work as type guard for optional string. And in order to fix this, I provided property that accepts type we are validating and returns nothing. And we never have this function, but the fact that we can have this function defined at any time makes this string not compilable. And
okay. This is quite some advanced stuff. So that is basically something you are never really facing as a user or as someone who uses that. It's rather a background thing that you just define there to make the types work.
Yes, but it's important because, for example, here unit, you can see it's optional. It may be undefined or string, but if there was not this hack, this thing would not make compiler scream, and instead you could have problems in runtime.
Okay, well, this is advanced stuff. I think in general, probably in the next advanced TypeScript meeting, we can talk a bit more about functional programming with TypeScript. I have the feeling that a lot of the advanced stuff is moving towards that. Many people are doing this kind of stuff. What you are showing here, FPTS, is probably still new to many people. I haven't used it, for example, yet. I know some basics, but for example, what this either type is doing and so on, I think there are also some basics on that level missing. It's always the question what you define as basics and advanced. But I think we can dive that into that another time. Awesome.
If we have a few minutes, I have one kind of slide for this.
We need to jump back to the
Yeah.
panel, let's say
Okay.
in 2 minutes. Okay. Natalia already made us jump back to the panel. That's also okay. We are already 5 minutes over time. I think next time we will take more time. So let's just round things up here in the panel. Again, thanks a lot, everyone, for coming. Maybe we can round this up a little bit by everyone just mentioning what their favorite part was today that they saw, or what their favorite thing is, what they're most excited about here, what we saw today. Let's start with Remo, because he hasn't said anything yet today.
Yeah, I really enjoyed the first talk. I'm very curious about how the lowercase type works, so I guess I'm going to go and check that later in the source code. I'm wondering if you can implement your own types like that, or if they're just built in and you only have a subset of types that you can use. So I will try to figure out that later on.
Awesome. Yeah. I mean, that's a little bit still the mystery. Someone wrote in the chat that pointed to the PR that apparently removed that type or something. It's still something to figure out. Simon, what was your,
actually, like the string typing is the most interesting to me also, because I'm not even sure if languages like Haskell have it. It's like a very unique thing. And Haskell doesn't have it. All right. So then TypeScript is the only language that has some kind of feature like that. And I'm really curious from like a compiler perspective how that's implemented to be any kind of efficient whatsoever. Like especially the string splitting type, it didn't seem like it could perform better than like a few miles per hour by feet.
Yeah.
It seemed really bad, and I'd like to know how well it performs in production, or how well it works with bigger code bases, actually.
Yeah, that makes sense. Jason, what was your favorite today?
The parsing was pretty cool, but it was also nice to see all the talks and how TypeScript's tackled as a way to enhance the developer experience, but also then needing to get out of the way to be extensible but not confusing. So it's an interesting kind of balance as the type errors get more complicated and less user friendly. How to balance these things. I think it's really good to have these kinds of like show and tells to explore these API services. It's great. But yeah, the string templating and spreading of generics, I'm personally interested in actually using those soon on a pet project. So yeah, looking forward, and it was nice to see that today.
Yeah, awesome. Yeah, thanks. Boom. What were you excited about? Or are you excited about?
Yeah, for me, I have looked into the awesome template literal types repo, and it's like amazing. Like you can see people making parser out of everything that has exists and ever will exist in the universe. Like I can't wait to see people just make random parsers.
So then we indeed probably have to see a bit how the performance really goes and how practical it then is, right? As Simon mentioned.
I see it in front of me. Next year, every university class on grammars is going to be taught in TypeScript.
I mean, performance also, probably we can have another talk one day. I mean, there are efforts in the Rust language, right, to re-implement parts at least of the TypeScript compiler. Maybe next time we have a Rust engineer explaining something like that to us. Bogdan, what was your favorite?
I like the things from Fum's talk about making the types with interesting conditions with a single line.
Yeah.
It was cool. I guess I can reuse it somewhere in our production code.
It's a nice pattern. I think I will also check a little bit in my library code where I can apply that. Yeah, awesome. And then last but not least, Craig.
Yeah, the module augmentation pattern scares the shit out of me, which means that I'm interested in it. I really want to I can't decide if it's my favorite idea ever or if there must be a better way. So I'm going to go dive into that a bit more. It's interesting to see that there are multiple libraries using that approach. So curious.
Yeah. I mean, it seems like it's a bit like you need first some libraries, like as thought leaders here going in that territory, because it seems a bit scary. But yeah, let's see how that goes. I mean, yeah, obviously it can be scary that you have some file laying around in your file system and suddenly that has a module that completely destroys everything, a model extension. I guess that can happen, but it can always happen. That you
Well,
have
maybe that's the thing that can come with TypeScript 5.0, like a native way for things to hook up into typings of your library.
Yeah. There's so much potential. Also, typing exports, interesting for Next.js, where you export a component, but you cannot really easily type that without adding like loads of type annotations. These kind of things, I think they're still really interesting to see how we can make it easier, because especially in the front end, I have the feeling that developers don't like to, if you come from JavaScript, you don't like to add all of these annotations and it's in your way. So if we can make it more seamless there, I think that's a huge win, definitely. And Anurag says in the TypeScript 99 beta, it will support Rust. I think the TypeScript 99 beta might compile Rust, and then have that.
It compiles Rust to YAML.
Maybe it'll give Idris a run for its money or something.
That's just when all the languages converge onto TypeScript as the one true language, right?
Yeah. First JavaScript ate the world, and now TypeScript is eating JavaScript. So, yeah. Perfect. Thanks everyone for coming, and thanks for sharing your ideas, your views on this. We will see. The idea is that we might be able to do this once a month. Let's see if we can keep that schedule up, depending on how many CFPs we have and so on. So yeah, thanks everyone for coming. And that's it for the first Advanced TypeScript Trickery Meetup.
Cool.
Bye.
Thanks, everyone.
Thanks for organizing.
Thank you.
Thanks to Natalia,
Thank
who
you.
did 99.9% of the work of promotion and so on. I mean, this was already much bigger than we expected. We first thought, like 10 people might watch this. And now we got 100 RSVPs on meetup.com. So yeah, this got quite famous. Thanks everyone for coming.